All right, so we're going to start chapter 2 today. This is for section 2.1, which is talking about properties of functions. This chapter gets into a little bit more nonlinear functions as we go along, things that we'll be using a lot as we go through this course. And so some of this will be a review from what we talked about in the 1.2 video, but we're going to get into a little bit more detail as far as properties of functions go and what we can do and talk about with them. So the first thing is the definition that we talked about last time. A function is a rule that assigns each element from one set to exactly one element of another set from another set. And so we can talk about domain. So we have two sets. And usually we call one set X. We call the other set Y. We take one element from X and then it maps to another element of Y. And you can kind of see this in this diagram down here that we'll talk about in a minute. The domain, like we said in the last video, is the set of all possible X values. So what are the values that we can plug into the function and get something out? So sometimes not all values of X work. Sometimes all possible values of X do work when we're talking about real numbers. So for instance, if we have, say, the function 1 over X, where X is in the denominator. So if we have something like that, you cannot put all real numbers in for X here. You cannot put, so X, for instance, cannot be 0. If you have something like square root of X, then X has to be greater than or equal to 0 because you cannot take the square root of a negative number. But if you have something like X squared, then X is all real numbers because any real number that you have, you can square it and get something back. So that's what we talk about when we talk about domain and the possible X values. Then the range is the set of all corresponding Y values. So when you plug in these possible X values, what are the corresponding Y values that you get? So if we talk about these three different functions, you could get negative Y values out of this. All you need to do is plug in a negative X value, which would work. So if you want Y to equal -1, then you need just plug in -1 for X, and then that gives you negative 1. Or if you want to get -1/2 back out of the function, you want Y to equal -1/2. Well, you just need X to equal -2. And so on and so on. So you can get negative Y values, you can get positive Y values. If you plug in a positive number for X, you get a positive number back for Y. Now you cannot get Y equal to 0. There's no value of X that you could plug in here that gives Y equal to 0. On the other hand, if you have the square root function here, there's no way to get a negative Y value back. So the square root, when we take the square root of a number, say square root of 4, the answer is 2. And so in this case, the Y values are always positive. If you want Y to equal 0, then just plug in X equals 0. The square root of 0 is 0. And then same thing here, these ranges are actually the same for X squared or square root of X. Anytime you square a number, it's going to be positive. There's no way to get to square a number and have it be negative, as long as we're only talking about real numbers. So that's what we talk about when we talk about the range. What are the possible Y values that you can get? So here's an example. So the purpose of this, is this a function? Is this a function? So we have a set of X values, so 16, 7, 9, 43, 28. We have a set of Y values, 60, 12, 19, 27. And we see these arrows going from the X values over to the Y values. So is this a function? Well, so the definition, the function is a rule that assigns each element from one set to exactly one element from another set. So 16, if X is 16, that maps directly to 60. If X is 7, that maps directly to 12. If X is 9, that maps directly to 12. So we have two things going to 12, but that is okay. We can have two things going to the same number. What you cannot have is you cannot have one number over here going to two different numbers over here. So 28, so this one's okay. 28, that is not okay. So we have 28 going up to 19, and we have 28 going to 27. So that tells us that this is not a function. So no, since 28 goes to 9 and 28 goes to 27. So if you see a picture like this, all you're doing is you need to look to see if there is some x over here that is going to two different y's over here. And then if there is, then it's a function. If all of these just have one arrow coming out of them, then it would be a function. So if we just delete one of these two arrows, then we would have a function. And it doesn't even matter. So even if we deleted this one and we don't have anything going to 27, that's still okay. We don't have to have an arrow going to every single number over here. Just like over here with the x squared, we wouldn't have any arrows going to negative numbers, and that would be okay. So as long as there are not two arrows coming out from one x value, then you are working with a function. If you have two arrows coming out from an x value, then you're not. It's as simple as that. So this next one, we can find the domain and range. So here we have this graph, and this is a graph that's just plotting ordered pairs. So most of the time when we talk about graphs, we look at different lines. You might have a curve that goes like this or whatever. You might have a linear function, but most of the time you're working with lines. In this case, we're just working with ordered pairs. And so when we talk about the domain of this, we just need to list the x coordinates that we see. So we see -2, we see -1, we see 0, we see 1, and we see 2. Then for the range, we just need to get those corresponding y values. So we have 4, we have 1, we have 0. Now we have 1, but we already listed 1, so we don't have to list it again. And then we have 4 again. We don't have to list that again. So only list things once. And the order doesn't matter. So when you're writing lists in set notation like this, these are sets. The order doesn't matter. You can list them in whatever order that you want. But you don't need to list things more than once. Even if it shows up 2 or 3 or 4 times, just list everything once. All right, here's another one. Find the domain and range for this guy. Y equals 1 over square root of x squared minus 4. And so this is not going to be a list of numbers, because you could plug in a lot of things for x. You could plug in integers, 2, 3, 4, 5, 6, so on. You could plug in decimals. You could plug in irrational numbers. So you could plug in pi. You could plug in square root of 9. You could plug in square root of 36, and those may or may not work, but there's no way to list all the possible numbers that you could get. So how do we find the domain of this function? Well, we know that the denominator, whenever you have a fraction, the denominator cannot equal 0. And we also know that when we take the square root, whatever is under here, so we'll just kind of write a squiggly, the squiggly part has to be greater than or equal to 0. So whatever is under the square root has to be greater than or equal to 0, and whatever is in the denominator cannot equal 0. So essentially, for this one, we need to figure out when is that bottom part positive. Because if x squared minus 4 equals 0, square root of 0 is 0. That is no good. If x squared minus 4 is negative, that's no good either, because we cannot take the square root of a negative number. So we just need to solve this. And when you have, this is a nonlinear inequality, so really we just need to worry about this, treat it like it's an equation, and then we'll worry about the inequality in a minute. So x squared equals 4. And we get x equals plus 2 or minus 2. So plus 2 or minus 2, negative 2 would also solve this equation here. Now, since this is an inequality, it's not as simple as just keeping the inequality going down And we're going to have to use this technique quite a bit in this class as we move along. So let's put these on a number line, and we'll test numbers that are outside, besides these two numbers. So anything that is over here is going to behave one way. Anything that is between these two numbers is going to behave another way, and anything that's over here is going to behave another way. And so we really just need to see, we're looking for any number that would make this x squared minus 4 be positive. So let's pick a number that's less than -2. We can pick any number we want. So pick an easy one, although that no number is harder or less hard, I guess, in this case. But sometimes that's the case. Sometimes it's better to pick easier numbers. So let's just pick x equals -3. So we can pick any number we want that's less than -2, but so -3 works. -3 squared minus 4 is 9 minus 4. That is going to be greater than 0. So all these numbers will work. Anything less than -2 will satisfy this inequality. Now let's pick a number between -2 and 2. So 0 is always pretty easy. So 0 squared minus 4, that's -4. That is less than 0. That is not what we want. So any number, and you test another number. You test 1, -1, 1/2, 1/3, whatever. Any of them that you pick in this interval will give a negative number, which is not what we want. Now let's pick a number that is greater than 2, and we can pick 5, you can pick 3, you can pick 2.5, whatever you want. So 5 squared minus 4, that would be 25 minus 4, that's 21. That one is greater than 0, so this works. So this means that the domain of this, let's kind of didn't plan to do the range here, I guess. The domain is all these numbers that are less than -2, so -2 to infinity, union to I did that backwards. Negative infinity to -2, union 2 to infinity. I did that interval backwards. But negative infinity, all of these numbers stop here. We don't want it to equal 0. If x is -2, then that bottom is 0. That's no good. Skip this part. All these would be negative. That's no good. And then if x is 2, that also gives us 0. That's no good. So then we want all of these also. So -2 to negative infinity to -2, union 2 to infinity. And that is our domain. All right. So we'll kind of go quickly through the range here. And kind of think about what I said earlier when we talked about the square root function before. If you take the square root of anything, you can only take the square root of positive numbers or 0, but in this case, you cannot do 0. So this denominator is always going to be positive because when you take the square root, you get the square root of anything is positive. So the range here is not going to be negative because there's no way to get 1 over a positive number and have it be negative. There's no way to get 1 over any number and get 0. So the range, so y can never be 0. So the range of this is 0 to infinity. And most of the time with the range, you're not really going to work it out too much. A lot of times it's just kind of thinking about what could you get. And if you want, you could graph this. And you're not going to have a graphing calculator on a test, but when you're doing homework, I would suggest that you use one to just kind of get an idea and a feel for what these graphs look like. But when you work with the range, a lot of times it's mostly just going to be thinking about, could you get a negative value? Could you get 0? Could you get a positive value? And if you can get a negative, could you get any negative? If you can get a positive, could you get any positive? Now, could you get any positive number from this? Well, you could. So if you want a small positive number, you just need this part to be big. 1 over a big number is going to be a little number. If you want y to be large, you just need this number to be extra small. So you need x to be closer and closer to 2, and then that will get smaller and smaller, and then it's 1 over a small number, and that gets big. So that's the idea. So thinking about this problem with the range, we're not going to be finding the range a lot, but it is a good mental exercise to kind of work through these and see if you can figure out the range without looking at the graph. If you need to look at the graph and then figure out what the range is, that's okay, but try to figure it out without looking at the graph. Or if you do look at the graph, try to see how you could have figured it out without the graph, if that makes sense. All right, so given the function f of x equals 2x squared minus 3x minus 4, find each of the following. So we did something similar to this one in the last video. So we talked about in the last video, how do you find f of 2? How do you find f of 5? How do you find f of t? And I said in the last video that whatever is in the parentheses, you're going to plug in for the x. So 2 times 2 squared minus 3 times 2 minus 4, or 2 times 5 squared minus 3 times 5 minus 4, or f of t, 2t squared minus 3t minus 4. So now, just keep that in mind. Whatever is in the parentheses, that's what you plug in for any x that is in the function. So whatever is in the parentheses, you need to plug in for this x and plug in for that x. So that one and that one. So f of x plus h will be 2. Now plug in, we have an x, so now plug in x plus h. Now be careful with your parentheses. So we're squaring x, whatever x is. In this case, it is x plus h. So we're squaring this whole thing. Minus 3 times x plus h. So we have 3x originally. Now we're plugging in x plus h, and then minus 4. Now just simplify this. 2x squared plus 2xh plus h squared minus 3x minus 3h minus 4. Distribute your 2. 4xh plus 2h squared minus 3x minus 3h minus 4. And then that's all we can do. There are no like terms that we can combine. And there we go. And so that is part A. So get used to using this f of x plus h. We're going to be using that a lot. We'll see it later, probably in the second part of this lecture. We'll be using this a lot. So get comfortable with how you plug in this x plus h and then how you simplify it once you do. So be careful with the parentheses. And if you need help, or if I guess another tip, so if we were finding f of 2, how do you do that? 2 parentheses, and then whatever's in the parentheses here, put in parentheses here. So use parentheses as much as you need to. Don't do something like this. This is not what you should do. 2x plus h squared minus 3x plus 8. That's not going to work. So use the parentheses. Whenever you have an x, just automatically parentheses. And then whatever is in these parentheses goes in these parentheses. So practice that enough that you can do this pretty reflexively. You don't want to have to think about this too much because there are a lot of places to make algebra mistakes, and you don't want to start off wrong originally. So, all right, part B, all values of x such that f of x equals 5. So if f of x equals 5, that means that 2x squared minus 3x minus 4 equals 5. So we need to find x so that this is true. So now 2x squared, this is a quadratic, so let's set it equal to 0. And you probably have tips or techniques for factoring quadratics that you've learned in algebra or pre-calculus. I am just going to do kind of a guess and check and see if that works, because if we have 2x squared here, we know this has to be 2x, and we know this has to be x. And then we have negative 9 here. So 1 is plus, 1 is minus, could be either way. And then we could either have 1 and 9, or 3 and 3, or 9 and 1. If I remember right, I believe it is 3. I believe that works. So 2x squared, we got negative 6x plus 3x. That gives us a negative 3x and then a minus 9. So that works. All right, so now we have 2x plus 3 equals 0, and x minus 3 equals 0. So set both of these equal to 0. And so 2x is negative 3, x is negative 3 halves, and x equals 3. So these are the two values of x that f of x equals 5. So if you plug in, so find f of negative 3 halves, you get 5. Find f of 3, you get 5. So f of negative, you can check this. This is how you would check the answer. So that should be true. And f of 3 equals 5. So if you want to check that, you can. And if you saw this on a test or a quiz where you can't see your answer and do it again, that's the way you would check it. All right, the next part, the vertical line test. If a vertical line intersects a graph in more than one point, the graph is not the graph of a function. So why is that? That is because so we see this, if so in this case, we have two x coordinates, x1, could be whatever number, x1 maps to y1 and x1 maps to y2. So that doesn't work. So that's why the vertical line test works. Because if a vertical line touches this twice or more than once, then you have x going to multiple y's, which is not allowed. All right, now the next one, we have a table. So does this define y as a function of x? And all you need to do again, does x repeat? Does x repeat? And we can see that it does. It does a couple of times. So yes, and so that means not a function. And then this last one, we'll pause the video and go to part 2 after this one. So does this define a function of x? So this goes to kind of knowing what a graph looks like, knowing different types of functions. So if you know, there are a couple of different things you call this. What kind of an equation is this? This is a polynomial. That's one thing you could call it. You could also call it a cubic because the highest exponent is a 3. That means it's a cubic. All polynomials are functions, which means all cubics are functions. All cubics are polynomials. Now, when would it not be a function? So sometimes it's hard to imagine something not having a certain property if you've never seen it. So something like this, not a function. Now, why is that not a function? If you have the y squared, it's not going to be a function. Or if you have y to the 4th equals x, or whatever you have over here, the y to the 4th, or any even exponent with a y, it's not going to be a function. Now, if you have y equals x squared, or y equals x to the 4th, these are functions. So those are polynomials. Those are functions. But if you have y squared, y to the 4th, etc., those are not functions. And for the most part, I think in this class, this would be the only non-function that we would see. All right, so that's part 1. We'll stop here and then continue in the next video.